All right, I just wanted to take a minute and go over your exponent rules just to make sure that you have an understanding of this before you take your quiz on it. All right, so a couple things. I'm just going to go through each of the rules, and if you have any questions, please feel free to reach out. All right, the first one is called the product of the powers. So what that means is if you have exactly the same base, so we have a base of A here, we have a base of A here, what you're going to do is you keep the base the same. So I have a base of A. I kept the base the same of A, and then I'm adding my two exponents. So that's A to the m plus n. All right, so here's an example here. You have 2 to the third and 2 to the fifth. These are the exact same base. So since the bases are the same, it's the same thing as you keep the base the same, you add your exponents, which make it 2 to the eighth. Now, the reason that works is think about this. 2 to the third is 2 times 2 times 2. 2 to the fifth is I would see that 5 times. Okay, if I were to count this out, I'd have 1, 2, 3, 4, 5, 6, 7, 8. Add an extra one in there. Okay, 8 of them. So that would make it 2 to the eighth or 256. Okay, now this one's a little bit tricky. If you take a look at this, you have two bases that are the same. So 2a and 2a to the third. So we're going to keep the entire 2a base the same, and I'm seeing this entire set of parentheses 4 times. So 2a to the fourth. So if you notice, this is essentially 2a to the first power, 2a to the third power. So you keep the bases the same, and you're adding the exponent of 1 plus 3 in order to get you 4. Okay, if you were thinking about this, writing it out, this would be 2a, and then you write this 2a out 3 times, and you see the entire base 2a a total of 4 times. Okay, all right, so right here we have the same base of a, so all we're going to do is add our exponents. 4 plus 3 gives me a base of a to the seventh. All right, now this one right here, once again, it's a little bit tricky because it's not a single base. So our base is xy. It's two pieces together. So it's xy to the -2 and xy to the 5. So what you're going to do is you're going to keep that xy exactly the same, okay? And you're going to add your two exponents here of -2 plus 5, which give me 3. Okay, so it's the entire thing, xy to the third. That means if I were to write that out, I would literally see xy, that entire base, a total of 3 times. So the exponent always tells you how many times you see that base, okay? All right, for letter E right here, we're gonna actually multiply 3 times 4. Those are completely different bases, so we don't have to do anything with those exponents. That's what gave us the 12. Since the base of x is exactly the same, we're going to add the exponent of 3 plus 3 in order to give me 6. Okay, now our second rule is the power of a power. And what that means is if you have a base that already has an exponent in it, what you're going to do, and then you're raising it to a power, which means you have an exponent basically raised to an exponent, what you're going to do is multiply those two exponents together, okay? So when you raise a power to a power, so here's my power raised to a power, you're going to multiply the exponent to every single solitary base inside the grouping symbol, okay? So here's just one example that can be a little bit tricky. So let's say we have 2x to the third raised to the second. Now here, you're going to just basically distribute this 2 to every exponent inside your set of parentheses. Now, we have two bases here. We have a 2 and we have an x to the third. There's no exponent on 2. It's an understood 1. So you're going to put that 1 there. So you're actually multiplying 2 and then 1 times 2. So you're going to give this exponent away here. So that makes this 2 to the second. Give it away to the third, and this makes it x to the 6, okay? So this becomes 4x to the 6. So just be careful. It's easy to miss if there is a base without an exponent on it. You want to make sure you put that 1 there so that you're distributing your 2 to every single solitary base with an exponent. All right, so take a look at this one. So we have 4 squared to the negative 3. So your base is 4. You're multiplying your exponents. 2 times negative 3 is negative 6. Now I'm going to tell you, you're never, ever, ever, ever going to leave your exponent with a negative. So we'll go over that in a minute. Okay, your exponent can never be a negative. You can have a negative out front, but never a negative exponent. Okay, now you want to be careful with this one. So this one says negative 2 squared to the third. All right, now that entire thing is raised to the third. So I could actually rewrite this as negative 2 squared. All right, now what's tricky about this one is the fact that this is kind of like negative 1 times 2 to the second. So really it's like saying negative 1 to the third, because that understood exponent is 1. And then you're saying 1 times 3 is 3. 2 to the second is going to be, you're multiplying the 3 times 2 to make that one 6. Okay, negative 1 to the third is negative 1 times negative 1 times negative 1, which gives me a total of a negative 1. So I'm just going to leave that negative there. And then 2 to the 6 is 64. So that's why that's negative 64. The other way of sort of thinking about this is saying negative 2 squared to the third. If you want to think about this, this is saying, see that entire thing 3 times. So negative 2 squared times negative 2 squared times negative 2 squared, okay? And then think about doing this. Negative times negative times negative gives you a negative, okay? And then 2 squared, 2 squared, 2 squared. When you add all of those up, that gives you negative 2 to the 6, okay? If you have any questions on that, let me know. It's a little bit tricky. All right, so this one right here, you have x to the second. So we're just going to multiply 2 times 2 to give me x to the fourth, all right? Now, the power of a product, this is actually what I was kind of talking about earlier up here, is whenever you have two bases that are inside your parentheses and are being raised to the exponent, you need to make sure that every single solitary base, their exponent gets multiplied by the power that it's raised to. So for example, if I were to write this, I could write this as a to the first, b to the first, all raised to the m. So now it's kind of easier to see what those exponents are. So you can multiply 1 times m, which gives you a to the m, and 1 times m here, which gives you b to the m. Okay, so notice how you're actually kind of distributing that m to the exponent on every single solitary base. All right, so let's just take a look at some examples here. So notice here, here's your two bases, x and y. You think they don't have any exponents on them, but they do. You can write this as x to the first and y to the first, all raised to the second, and then you're multiplying 2 times 1 to give you x to the second, y to the second. Okay, this is one of the ones that's a little bit tricky. You have three bases here, 3, x, and y. If you have to write the exponent, you can. 3 to the first. It's not there, it's invisible, but you can always write that 1 there. X squared, and then y, same thing, that has to the first, all raised to the fourth power. So this 4 gets distributed to every single solitary exponent to make that 3 to the fourth. 4 times 2 is 8. 1 times 4 is 4. And then you want to actually simplify this 3 to the fourth to give you 81. Okay. All right. So let's take a look at this next one. Once again, we have a total of 1, 2, 3 bases. If you want to, you can write this as negative 2 to the first. Okay. And then you have x to the third and y, nothing there. You can put that first, all raised to the second. Now, this negative right here, you can also take a look at the negatives and see if this is even or odd. Since this is even, you know, your negatives are going to be multiplied twice, which is going to make them positive. Okay, so that's going to make that a positive right here. Then you're going to have, or you could put this in parentheses, then 2 with the negative with the 2. Or you could write like a little 1 there. So many ways to do that, but we know we're going to see 2 negatives, which is going to make my entire answer positive. So you're going to do 1 times 2, that makes it 2 to the second. 3 times 2, which makes it 6. 1 times 2, which makes it y to the second. Okay, just make sure you simplify 2 to the second. All right, rule number 4 is negative power property. Okay, so exponents are happy. We always want happy exponents. What does that mean? That means in our final answer, we're never, ever, ever going to have negative exponents, all right? Now, so what the rule here is if you have an base raised to a negative exponent, here's what I always do. I always just make like a fraction bar, and I say, okay, right now this base has a negative exponent, not very happy. Where is it located? It's actually in the numerator because I could put a 1 underneath it. So to make it happy, you have to move just the base connected to the negative exponent. Okay, you have to move just the base connected to the negative exponent to the opposite. So right now it's in the numerator, it's going to go to the denominator. When you move it to the denominator, you're going to make the exponent positive, okay? So a to the negative n becomes 1 over a to the n. So we move the base to the bottom, made the negative exponent become positive, okay? Right here, you have a 1 over negative a to the n. Exponent's not happy, it's in the denominator, so we're going to move it to the numerator, okay? And you're going to keep your base the same and make the exponent positive. All right, so basically, if it's negative on the top, it goes to the bottom. If it's negative on the bottom, it goes to the top. So we're going to look at each of these examples piece by piece. So x to the negative 7 is on the top, so we're going to move the base to the bottom, pop it in the denominator, and make the exponent positive. And when you pop it to the denominator, you'll notice you're like, nothing up here. So you just want to put a 1 there, okay? All right, now this one right here says 3x to the negative 2. So what I do is I just draw a fraction bar, and I look at this base, and I say, hey, this base has a positive exponent of 1. He's happy where he is, so we're going to leave him right where he is in the numerator. This base has an exponent of negative 2, not happy, need to make it happy. So to do that, we're going to move that to the denominator. And when we move that to the denominator, the exponent becomes positive, okay? This one right here, all right, so this is like a double step one. So it's on the top. We need to make it happy. This negative 3, you can do this a couple of different ways, but this entire thing is your base. That whole thing is raised to the negative 3. So when we pop that entire base to the bottom and we make that 3 positive, make sure you keep that parentheses, because now we're going to use our other rule that says, hey, I got to get rid of these parentheses. Okay, this has an exponent of 1, this has an exponent of 1. So I need to distribute this 3 to each of my exponents on my bases. So this becomes 4 to the third, x to the third, and then 4 to the third is 64, x to the third. Okay, now this one's a little bit trickier because we got some negatives and positives and lots of stuff going on. All right, now don't let this negative 3 fool you. It's okay to have a negative number, not a negative exponent. The exponent on this negative 3 is 1. So this 3 is happy where it is. So we're going to leave the negative 3 in the numerator. Okay, so then the next thing we have is x to the negative 2. So that's not happy, so we're just moving the base of x. Notice I did not move the negative 3. The negative 3 had a positive exponent. When I move it, okay, it becomes a positive exponent on the bottom. Y to the 4th, happy where it is, we're going to leave it as y to the 4th, okay? This one right here, if you have 2 over x to the negative 2. So right now, if you're going to, make your fraction, you're like 2 is happy where it is, so we're going to leave it. Okay, x to the negative 2 is in the bottom, not happy, so we have to pop it to the top. So when we pop it to the top, we're going to make the negative exponent positive.